Welcome to the solutions to the equilibrium problem set, problems numbers 10 and 11. Number 10, if the torque required to loosen a nut that is holding a flat tire in place on a car has a magnitude of 40 Newton meters, so this 40 Newton meters is the torque. What is the minimum force, F, that must be exerted by the mechanic at the end of a 30 centimeter lug wrench to accomplish the task? The 30 centimeters is the lever arm distance as pictured in the diagram. So here we have a force on the end of the handle, 30 centimeters from the pivot point, and the pivot point, the distance from the pivot point to the force is the lever arm. 30 centimeters is 0.3 meters. And so we can go ahead. This is just a simple torque calculation question. RF sine theta. Since the force is already perpendicular to the lever arm, that means it would be 90 degrees. As you know, the sine of 90 is 1. So we can just drop that off altogether. Our torque is 40 Newton meters. Our lever arm distance is 0.3. And we're looking for F. Go ahead and solve for F, and you should have gotten an answer of 133 newtons. Okay? So that's the minimum force that the mechanic would need to exert to break that nut free of that torque that was used to put the nut on. Okay? All right, let's move on to number 11. Give me a moment here. Okay, that's better. Here we got the net. We need to calculate the net torque, magnitude, and direction on the beam shown in the diagram below about. And in A, they pick an axis through O perpendicular to the page. And B, they pick an axis through C perpendicular to the page. I'm going to color code these two solutions. We're going to do A in blue, and then I'll do B in red. Okay? So A in blue here, we have an axis perpendicular through O, and what that means is that let's first sketch out the components on our diagram here. None of the, as mentioned in a previous video, none of the three forces here are perpendicular to the lever arm, to the beam itself. So we have to find the components that are. And this would be 30 sine of 45. This component would be 25 cosine of 30 degrees, because that component is adjacent to the angle and not opposite the angle. And then this component on the 10 Newton force would be 10 sine of 20 degrees. Okay. By selecting the pivot point to be at O, what we have here is we've eliminated the 30 Newton force as causing torque. So here's how we set this up for A. You have sigma tau equals, and what I recommend is that you just go one force at a time, starting from the pivot point and move away from the pivot point. The 30 sine of 45 doesn't create any torque because it has no lever arm. So the R value is 0, so there's no torque there. The 25 cosine 30 does cause torque. What is the 25 cosine 30's lever arm distance? Well, that's the distance from the pivot point to where that force is attached, which is 2 meters. And what we do now is we determine by itself what direction would it cause the beam to rotate about the pivot point at O. Well, this would cause the beam to rotate upward and around O in a counterclockwise direction, and that direction is deemed to be positive. The next force that we have is the 10 Newton sine 20 force. So we have 10 sine 20. What is the 10 sine 20's lever arm distance? The distance from the pivot point to where its force is attached is 4 meters. Now we consider what sign is that torque by itself. What direction would it cause the beam to rotate? And by itself, it would cause the beam to rotate down around the pivot point in a clockwise direction. Therefore, its torque rotation is negative. We go ahead and we solve this problem, and we get a value that's 29.6 Newton meters, which is the smartboard freaking out here, which is the unit of torque. And because our value turns out to be positive, what that does is it tells us that that rotation is counterclockwise. Okay. All right. Next, we're going to do B. And they're selecting, in this problem, the pivot point to be at point C. So what would be the torque at about an axis of rotation through the pivot point at C? And so setting this up, this helps a little bit of room here. For B, again, you start at the pivot point and make your way away from the pivot point. In this case, the pivot point's halfway in the beam, so it doesn't matter which side you pick. We'll pick the left side first. So our summation of torques is going to be that force, which is 30 sine of 45. How far away from the pivot point is that force attached? In other words, what's the lever arm? And that's 2. Now determine its sign by what rotation itself would cause. And by itself, the sine 45-degree force would cause the beam to rotate down around the pivot point in a counterclockwise direction, so its sign is positive. The 25 cosine 30 force doesn't cause any torque because it has no lever arm. So since the lever arm distance is 0, it caused no torque. So now we go to the sine 20-degree force. What is its lever arm distance? Distance from the pivot point to it is also 2 meters because the pivot point is halfway in the beam. The beam's 4 meters of total length. Now determine its torque rotation. By itself, it would cause the beam, the right side of the beam, to rotate down, causing the beam itself to rotate in a clockwise direction, which would be a negative direction. Solve, and we again get a value, let's see here, 35.6 Newton meters. And because that value is positive when we calculate it, it tells us, once again, that the net torque is in the counterclockwise direction. All right, there you have it, 2 introductory torque problems, and more to come tomorrow when we do problems 12 and 13 in class.